Alright, what's up guys? In this video we're going to pick up some multivariable calculus. We're going to be talking about the Jacobian here. So we're asked to evaluate the Jacobian for the following transformations. Basically what we're doing is we're looking for the Jacobian determinant, and they give us the transformations here, x, y, and z. So the Jacobian can be evaluated as well with two variables, but in this case we're obviously going to do it with three. So for practice with this, obviously you would certainly want to start by just doing it with two variables before moving on to three, but it's a relatively straightforward process. And so let's go ahead and do it here. All right, so we obviously know we're talking about three variables here. So it's going to be j of u, comma v, comma w. Remember, that's just equal to partial x, comma y, comma z over the partial u, comma v, comma w. And what you do is you set up the 3 by 3 matrix. It's basically the matrix of these partial derivatives. So it's going to be the partial of x with respect to u, the partial of x with respect to v, the partial of x with respect to w. The second row here will be the partial of y with respect to u, the partial of y with respect to v, the partial of y with respect to w. And then our third row will be the partial of z with respect to u, the partial of z with respect to v, the partial of z with respect to w. So what we're going to need to do is compute the Jacobian determinant, which obviously is just the determinant of the 3 by 3 matrix. So to do this, you will need to be familiar with some basic linear algebra, working with matrices and determinants, and obviously you'll need to know how to take partial derivatives. But other than that, it's a relatively straightforward process here. So let's just go ahead and get the partial derivatives, and we'll go ahead and do it. So let's get the partial of x with respect to u. So remember, for partial derivatives, if I'm in this case taking the partial with respect to u, then that means I'm treating any other variables as constants. So if we go up here to our transformation for x, we got v plus w, where there's no u in there, so that's just 0. So we're treating v and w as a constant anyway. Then we need the partial of x with respect to v. Same thing. So if we go up here, well, we're treating w as a constant, so that's just 1. And then we need the partial of x with respect to w. Okay, and what do we get for that one? Well, we just get 1 as well. Next, we need the partial of y with respect to u. So we go up to our transformation for y, and we clearly see we just get 1. We now need the partial of y with respect to v. And for that, we obviously get 0 because there's no v in there. Then you need the partial of y with respect to w. Same thing. Go up here, we're going to get 1. Now we go down to our transformation z. Same process here. Well, I'm just going to get 1. And then the partial of z with respect to v. Okay, well, that's 1 as well. And then we need the partial of z with respect to w. Well, there's no w here in our transformation z, so that's just 0. So those are the partial derivatives. And now all you do is compute the determinant, and in this case it's obviously going to be the determinant of the 3 by 3 matrix. So you set up your matrix. All right, so we got our 3 by 3 matrix here. Make it nice and big for us. So the first row, just use your partial derivatives. So your first row in the matrix, that's going to be 0, 1, and 1. Second row here is going to be 1, 0, and positive 1. And then 1, 1, and 0 will be the third row. And we need the determinant here. So I can pretty much kind of tell what the determinant is going to be for this matrix, because if you notice here, we got zeros along the main diagonal. So we're going to get 2, because if we add, we get 2 here. Let's just say if we added the 1 and the 1, will we get 2? 1 and 1 here will give us 2. 1 and 1 will give us 2. So Jacobian determinant is going to be 2. I don't recommend, obviously, guessing at what the determinant is that way. I just can easily tell what it's going to be just by kind of looking at it. But we're going to go through the whole process of taking the determinant, and I'm going to show you all the steps for it. So don't ever guess, but sometimes you can easily see in some cases, because all we got is 1s and 0s in there. So it's very easy to see. So remember what you do for the determinant of a 3 by 3. You go up to our first row, and we're going to pull out the first entry in the first row. Okay, and then the first entry in the first row is 0. We'll multiply that by the determinant of what's left over when we cancel out the column and row containing the entry that we pulled out. So in this case, and it's best to do this with like a pen or maybe a piece of paper. And by the way, once you start learning about this in multivariable calculus, you will have already worked with matrices to an extent, because to calculate the cross product of two vectors, we use the matrix method. So when you get here, you'll already know how to do this. But again, I'm just going through the whole process here. So when I cancel out the column and row containing the entry that we pulled out, we see that we're just left with 0, 1, 1, and 0. Then it's going to be minus, and we're going to pull out the 1, and we're going to multiply that by the determinant. And we want to get rid of the column and the row containing that entry. So that just leaves us with 1, 1, 1, and 0. And then this would be plus 1 times the determinant. Looks like I'm going to run out of room, but I'll try to fit it in here. And we want to eliminate the column and row containing that entry, which obviously will be this part. So this goes and that goes. So we got 1, 0, 1, and 1. Now, essentially, whatever the determinant that we get for this doesn't matter, because we're multiplying by 0, so it doesn't matter, but we'll go through the process here. So 0 times 0 is 0, and we got 1 times 1, which is 1, but again, we'd have to multiply by 0, so it doesn't really make a difference, but we'll write it down anyway. So this would be 0 multiplied by negative 1, so that's what we'll get. Determinant here is negative 1, by the way. Go over here. And the determinant here is going to be negative 1. And the determinant over here is going to be positive 1. So this would be minus 1 multiplied by negative 1. And then this would be plus 1 multiplied by 1. And obviously, it's just going to give us 2, which is the Jacobian determinant there, which I mentioned up here at the beginning. So your final answer for this, and we were just looking for the Jacobian determinant. So the Jacobian determinant here is going to be 2, or we'll write it as J of U comma V comma W is equal to 2. All right, so that's how you do it. So this was a relatively easy one, but they can get more difficult than this. I have done plenty of examples where it's a little bit more involved, but this one was a very straightforward one. Okay, so that's your answer. So let me know if you got any questions, and I'll see you next time.